Good morning, everyone. Oh, I really don't need to speak that loud, do I? Okay. Hi, I'm Russ Scammell. I'm the product manager for 2D with Unity. And today I'd like to talk to you about some of the new 2D features, some of the new developments in the 2D tools in Unity. I'd like to find out about the guys in the room, the guys and girls in the room. How many of you are programmers? Let's see, always well represented. Oh, okay, nice. How many artists? Designers? Get a show of hands. Okay. How many producers in the room? Ah, okay, these are the secret heroes, right? You are the guys getting it done. Very cool. How many of you are completely new to Unity? Completely new. Oh, interesting. And new to 2D games. Who's completely new to 2D games? Okay. How many of you have already made a 2D game? Can I get a show of hands? You've already made one. And of you, how many of you have shipped your game? Oh, that's interesting. Some of you have not made one, but you've shipped one. I need to understand that. Okay. So I'm going to talk a little bit about what we've released earlier this year, but very briefly. And then I'm going to focus on the first of our world-building tools. So it's been a really interesting year. We've released a lot of good stuff. We started with 5.6 and 9 slice, which allows you to kind of control where the tiling happens in a sliced texture. So this is really good for creating layouts that are adaptive to, for example, if you're making platformers or you're trying to create the floor for your level. We also added editing of the sprite outline so that when you bring your sprites in, you can control what that mesh looks like. Right? This gives you the ability to trade off between poly count as well as against alpha overdraw. It's really powerful. We also did a lot of work in sorting. So the sorting group component allows you to control kind of the rendering order of your sprite renderers. A good example of this is when you have a character that's made up of multiple parts, and you want those parts to render together and in a particular order. And then when you have other characters, you want those characters to be sorted as a group. We also added axis distance sort. So typically in a lot of 2D games, when you're making a platformer, you want to sort those characters or those renderers that are higher up on the y-axis behind those renderers that are lower down, right? Or you may have a special case for your games where another axis is important. So by extending the way we do sorting along an axis, you can now create sorting that follows an arbitrary axis. Lots of improvements in physics as well, and more to come. So we added the contacts API, so you can find out more about how your colliders are interacting, where those points are. Composite collider 2D. This is really powerful as well. By combining colliders together, you don't have to keep on rebuilding those polygon shapes for your levels. And it gives you a more optimized collision shape. Edge radius and distance features to give you more control over your colliders. And also, all of our particle collision code was rewritten. So when particles collide with 2D colliders, that's a lot faster because it's been rewritten in SimD. And then with 2017.1, the first of our bigger non-foundational features was released, and that's Sprite Atlas. How many of you guys use any kind of atlasing in your games? Right? So you're gonna want to explore the Sprite Atlas because a lot of the workflows have been improved, and the idea really is to supplant the sprite packer that we currently have. So where previously you would use packing tags, you now create an asset called a Sprite Atlas, and you can pack your individual sprites as well as your textures, or you can just pack a whole folder. Right? And this is really powerful because when you build the game, we check the contents of that folder, and based on what works for your production, you can place maybe all the sprites from level 1 into that folder, or everything from your swamp level in there, and that gets automatically atlased. It also gives you more control. So this, again, this is from chatting with a lot of developers, a lot of you, and you said you wanted more control over those atlases. You wanted to be able to do something with them. So now you can explicitly set those texture settings, and you can do per platform overrides as well. So you can have different atlases for different platforms. You can make variants. So if you're trying to solve the problem of high definition versus standard definition for different platforms, that is something you can do easily. You can use a get sprite method with an atlas. So you can just extract a sprite out of an atlas and do something with it. And because they are assets, you can, of course, add them to asset bundles. And this solves a lot of your deployment problems. We also created the sprite mask. So the sprite mask component is a way to hide or reveal parts of a sprite or groups of sprites. Right? So here we've got Rory the lion, and we're trying to make sure that he's masked that nice effect in each spectacle so that he can look really cool and ready for the party. Right? But we also made sure that it works together with sorting groups so that you can actually scope how that masking works. So here we've got different masks acting on the different sides of his spectacles. And as you can see, that works with particle systems as well. So if you want to mask particle systems, there's your solution. We added the physics shape editor with 2017.1, which means that as well as changing the sprite outline, you can change the physics shape that gets generated when you add a collider or a polygon collider specifically to one of your sprites. So this gives you finer control over what those collisions look like and what those shapes look like. Okay, so there's been a lot of stuff, and I wanted to make sure that we knew that all of that was there. And how many of you have started using some of those features from 5.6 and 2017.1? Can I get a show of hands? Right, okay, cool. So now you know they're there. I would love to know, maybe later on you can tell me if you've used them in your projects. You can give us some feedback. Tell us what you thought. I'm going to spend a fair amount of time now talking about tile map. I'm really excited about this. This is our new solution for doing grid-based layouts in 2D games. I'd like to jump straight into Unity and kind of show you live, get away from the slides for a bit. So we're going to be playing with tile map for the next few minutes. Before that, I want to talk briefly about the import pipeline for tiles in Unity. And you basically take whatever you've made in your art tool, bring them into Unity as sprites, and then we have another asset called a tile asset that uses those sprites. And the reason we did this rather than using the sprites directly is it means that we can have a little bit of extra data around that image. Like we can change the tint, or we can add transform, stuff like that. It also means that we can do some really cool things with the tiles themselves. And we're going to explore some of those. OK, let's play with tile map. OK, so we've got a demo scene here with a character. This is our robot from the RoboDash demo. And he's kind of moving around in a weird way because he's got a follow cam on him. But we're going to add some background to the scene, and then we'll see how that all changes. So to create tiles, it's a really simple process. I'm just going to come in here and create a new palette. So the palette is where you do all your staging for your tiles. And because I'm really creative, I'm going to call it my palette. Okay, I'm going to save that in the scene, in the project, sorry. And then now I can just drag the sprites that I've imported directly into this. So what I'm going to do here is I'm going to drag this sprite, drag it straight in here. It asks me where I want to save it. I'm going to say here, please. And we just generate a bunch of tiles for you. Simple as that. Now, I can just pick these tiles up and start painting them in the scene. And we're going to do that in another project. Okay, so as you can see here, I've been dragging in a few sprites. I've created some tile sets. And they don't have to be grids, right? As you can see here, these are kind of more organic shaped plants. We can use those as well. And I want to draw your attention to the scene as well. So these are the actual tile maps. Here they are, right? Tile maps. And they come with a tile map renderer. And you can have more than one of them, right? So again, we're stepping away from the more traditional idea of tiles that are very fixed in space. These are just game objects. You can move them around, you can rotate them, you can scale them. So you can play with multiple layers and really get make good use of the fact that you're working with multiple grids. So I'm going to show you a little bit of painting. So I can just come in here and pick something from the tile palette and just start painting it on a tile map in the scene. Right, so in order to choose which tile map I'm putting it onto, you want to select here the active tile map. So I'm going to start painting on the floor. Okay, and I want to move a little bit faster than that. So what I can do is I can pick multiple tiles, and I can come over here and use the box fill tool. And if I use that, I can very rapidly fill up a space in the scene. And then I want to put in the walls. So I can grab a bunch of tiles there and just start painting in here. We have shortcut keys for rotating those. Those are the square brackets. Right? So you can imagine artists and designers coming in and just really working very quickly to generate a level. And while I'm talking to you here, I've already started putting together the beginnings of a pretty cool level. And then here we go. Let's grab that plant. Maybe I'll put that on a plants tile map. Okay, pretty good. Let's hit play. Okay, and just like that, we've got a level. We can start moving the character around. It's multiple layers, right? So I can go behind the plants, but on top of the walls, and I can even leave the level completely. Okay, now I don't want my players to do this, right? So what I'm going to do is I'm going to add a collider to the walls. I'm going to explore the different ways you can do that. Okay, so let's take a look at collision. Okay, so what we want to do is we want to explore two different ways of adding colliders. And I want to draw your attention to a specific parameter in the tiles asset that is important for this. So the first scene we're going to look at is grid collision. And the way you add a collider is quite simply go to the tile map where you want this to happen and add a component, tile map collider 2D. Okay? And you can see in the scene we already have these green colliders on the walls, right? So I've selected the walls tile map and I've added a tile map collider 2D. And the reason we're getting the squares, the grids, is because these tiles themselves, if we look at them, these are the tiles. The collider type here is grid, right? So we're just going to take that grid, and anytime you've filled it with a tile, we're going to put a collider in there. Now let's say you have a slightly more intricate level, right? Where the walls are thinner than the size of the cells. And what I want to do is I want the player, when he collides against the edges, to only stop at this point, right? To only be stopped at this point. So what I want to do here is I want to go into the walls again. I'm going to add the same thing, Collider 2D. And you notice that automatically I've got colliders that follow that very thin shape on the edge. It's not following the grid anymore. And the reason for that is, if we look at the tiles that we use there, we used a collider type of sprite. Okay, so that's the main difference. And if we dig into the sprite itself and explore it in the sprite editor, and we open up the physics shape, we can see that we've defined a physics shape for each of these edges. Cool? And then finally, if we take these walls and I add a composite collider 2D, and I make sure that the tile map collider is used by this composite, I'm going to get a more optimized collision shape. Right? So this is now just polygons, or outlines rather. Okay. So I'm going to hit play, and we're going to see a little bit of interesting behavior, but I just want to draw your attention to it, just to hammer home that tile maps are not fixed things on a grid. You can play with them in interesting ways. So we've got a collision on the wall here, and when I run into it, the whole wall moves, right? That's a tile map. It's just a normal game object with a rigid body 2D on it. So maybe you've got a game idea that's emerged just from seeing this, right? I know that's how my brain works. So of course, we don't want this. We want the boring one, right? Where we change rigid body to static, and we hit play. And for the purposes of the demo today, you get exactly the behavior you wanted, which is limited right at the edges of the collider. Cool. Okay. So far, we've explored creating tiles and painting them to the scene, and that's kind of the basic information that you need for using tile maps. We've also been using just ordinary tiles, right? And when you paint an ordinary tile, you just place it down, and it puts down the tile, some color information, and position at a cell point. So what I want to explore now is scriptable tiles, right? These are custom tiles that you can make yourself by extending the tile class. But what we're going to explore, and all the examples that I'm showing you today, I'll make sure there are links for you to follow to get them and to play with them yourselves. What I'm going to show you is tiles that have been extended and can do more interesting things. So let's start with some scriptable tiles. Ooh, I gave it away. We'll come back to these. Okay. So very simple place to start is with animated tiles, right? Immediately, a lot of you will want to make some animation. A good example of this is here, a sequence of sprites. So what we've done here is we've extended the tile class, right, which is in itself a scriptable object. So then we can make an asset from that. And here, because of a custom editor that we've added to the script, you can see some UI representing how this custom tile works. So this is a custom tile that brings in multiple sprites, and you can set up kind of timing and speed for the animation, and you can set up the number of sprites that you want to use. And again, these are just normal tiles, so I can just come in here and paint them into the scene, grab these, paint these in here, hit play, and we've got animation, right? So very often, also, you may want to set up tiles that have a little bit more intelligence, that understand kind of, they have awareness of the other tiles around them. So I'm going to pull up the terrain tile set for this. So in this example, we've got these terrain tiles. And if we look at the terrain tile asset, we can see that there's a bunch of rules that it's following, right? So is it completely filled? Does it have neighbors on 3 sides? Does it have neighbors on opposite sides? Is it a corner piece, right? And all of this stuff has been set up. So when I bring this into the level, you can see this is quite pleasant to work with. You can see that it's aware of the fact that there are other tiles nearby, and we choose the correct sprite to place based on that. Now, whenever I show this to people who have designed tile sets, they always have ideas of things that they would want to do, right? Different rules that they would want to apply. So one of the things that we've included is a way for artists and designers to do this themselves without having to extend the tile class at all. And this is what we call the rule tile. So let's look at some rule tiles. Okay, so if we look at the rule tiles here, let's look at a simple one. Let's look at the ladder tile. So the UI for this has been designed so that artists and designers can add tiling rules, right, to kind of define the relationships between neighbors. So in this case, the rule is I'm fixed. I want this sprite. I don't want to rotate it or mirror it. The collision type is sprite, what we spoke about earlier, and the output is just a single thing. We're not animating it, or we're not trying to randomize it. And what I get from that, after I set up the rules about where the neighbors should be, I come in here and I can just paint in the level, and I always get a ladder that starts and ends and has a middle section, right? So we've got different rules for these different examples here. And again, I'm going to give you a link to all of these so that you can explore how the rules come together. In this case, we've recreated the terrain tile, but as a rule tile. And in this one, for example, we even have some animation. So if I hit play, you can see we've got a little bit of ocean animation on that one. Cool. Okay. So the other thing I want to talk about is brushes. So far, everything you've seen has been done with the default brush, which means when I paint, I'm just going to paint a sprite, right? When I do a box fill, I'm going to fill all of those cells with a sprite. Now, brushes are a little bit more interesting. We can decide to do different things on those operations. So we can override what paint means, and we can override what erase means. So what I'm going to do for that is I'm going to show you a game called RoboDash, which makes very creative use of brushes, and we're going to explore some of the ways that they've done things. How many of you have played the RoboDash demo? Can I get a show of hands? Nope? Okay, cool. It's going to be fun. Okay. So the very first thing that RoboDash does, which is kind of cool, is they've overridden the default brush itself, right? Here, the game detects that you have an empty scene. So because you have an empty scene, this is the brush logic that's doing this, by the way. It gives you a button down here to initialize that scene. So imagine your workflow as you're about to start making a game. You give your designer an empty scene, and he just goes, initialize scene. Right? So that was done with a brush. Just by hitting that, we've set up the right tile maps. We've set up a start and end. And if I hit play now, I already have a game. Right? It's the most challenging game in the world because just like that, I've won. Right? Not bad. See if I can beat my own high score. Now, I want to show you a couple of other ways that we're using brushes here. So what we've done is we've added functionality to the brushes. So you're not just painting sprites into the scene, right? You're painting gameplay elements. So one of my favorite examples is the laser brush. So when you use the laser brush, you come in here and you place down laser turrets, right? And those turrets have a memory of where the last turret was, so that they will keep on building a connecting laser, a connecting beam to the previous turret. And if I hit play, see, just like that, we've got some laser turrets. Now, I don't want to be, I don't want to oversell this to you. A lot of this had a little bit of custom shader work done, but the basic premise is that we're placing down gameplay elements, right? And we do this by overriding what paint means or what erase means. Cool? I'm going to show you one more example. So here we have a rail turret. So in this case, we've got, we're going to paint a rail down, and then we're going to place a robot on top of it. So the first click uses something like those tiles that we saw earlier, right? And then the second click places our enemy. And we hit play. And there you go. So just like that, you've got a game going, right? And I'm, of course, terrible at this game. So I'm sure you guys will do a lot better. There is one more thing I want to show you, which is the level brush, where they're painting in this example. We're painting to more than one tile map at the same time. So if I come here and I choose the level brush and I start painting in the scene, I can just start setting up rooms like that. And then because I've got something like a terrain brush, a terrain tile, sorry, on the walls, we're choosing the right corners and the right pieces for each of those rooms, and then we're just connecting them automatically. Okay. Cool. So that's RoboDash, and that's custom brushes working with custom tiles. All right. Let's get back to the slides for a little bit. So we've skipped through a lot of this. I'm very happy we were in Unity for most of that. So what I'd like to share with you now is some of the tools that are currently in development. The next one is very, very soon to be released, and that is Sprite Shape. So this is a world building solution as well. And this is for making more organic spline-based layouts. So if you look at the example there in the scene, you can see we're tiling sprites along a spline. And it's just adapting, it's just tiling those sprites nicely. So we're making modifications to the ground here. And then after that, some modifications to the trees. And even the trees in the background, those are sprite shapes as well. So they're just filled with a gradient fill. And then you can change the shapes around that. So this is to create a more fluid workflow for designers who are trying to make organic shapes in their levels. Cool. Also coming soon, well, a little bit later, is character animation tools in Unity. We are bringing in native skeletal animation into Unity, so you'll be able to bring in your sprites, rig them, set them up for your characters, do all the skinning, and then a lot of this will be built into the sprite editor that you already know. Cool. Now, all of the stuff you've seen so far, except for those last two features, are available online, right? So please, this is the slide that you want to take a photo of. We want to make sure that you have access to all of those brushes and tiles and everything that we did so that you can understand how they were put together and hopefully make some of your own, maybe put them on the asset store, maybe use them in your studios, right? We also have 2D tech demos. So sometimes we get questions about, hey, can I do this or that with TileMap? And if we've made an example, that's going to go up there. That really cool game with all the different custom brushes, RoboDash, that's available there as well. And I want to encourage you to drop in on the forums, give us your feedback, try out the new experimental features when they come out. Are we good? Anyone else need a photo? Okay, cool. I want to briefly talk about our process because this is really important to me. We are making tools for you. And we want to make sure that we're making the right tools that you can use to be successful. So we work on this based on what's missing from our current tool set, of course, but feedback from our community via forums, studio visits, and feedback on the previews that we have. So what can you do? Let us know what is working, because sometimes, if it's working, everyone keeps quiet, and that's good. But it would be really nice to know if the tools we've made are a good fit for your production. Tell us what's missing, of course. Tell us what's broken. You already do that. Keep doing it. We want to hear more because we want to make sure we give you guys a robust product. Any improvements and enhancements we might need, right? And share your 2D development workflows with us, if possible, so that we can understand how you are using our tools and how we can further support what you're doing. And of course, keep making amazing 2D games in Unity. Thank you very much.